In the last 50 years, our telescopes have caught 4 signals that should not have existed. One lasted 72 seconds and never came back. One seemed to come from the star next door. One turned out to be hiding in the observatory's own kitchen. And one wasn't a radio signal at all. It was an object passing through our solar system, quietly speeding up. 4 signals. Science managed to explain 2 of them. I'm Rook, and tonight we're going through all 4 in order of how close each one came to being the discovery of the century. Number 4. The peryton problem. For 17 years, starting in 1998, the Parkes Radio Telescope in Australia kept catching brief, strange bursts of radio energy. Astronomers called them perytons, after a mythical creature. They looked frustratingly similar to real signals from deep space. But something was off. They only ever appeared during office hours, mostly around lunchtime. Think about that. A cosmic phenomenon that keeps business hours. In 2015, researchers installed a new interference monitor, and the mystery collapsed in the most humbling way possible. The perytons appeared when someone opened the door of the observatory's microwave oven before the timer finished. 17 years of mysterious signals from deep space, produced by impatient scientists reheating their lunch. I love this story because it's the cautionary tale the other 3 have to live with. Sometimes the impossible signal is a kitchen appliance, but here's why perytons matter beyond the joke. While chasing them, astronomers confirmed that other bursts, the ones arriving at all hours from fixed points in the sky, were real, fast radio bursts from billions of light years away. Cleaning up the fake mystery helped prove a genuine one. Number 3. BLC-1. Due in April and May of 2019, the same Parkes telescope was listening to Proxima Centauri, the nearest star to our Sun, when it caught a narrow radio tone at 982 MHz. Narrowband signals like that don't come from nature, but pulsars don't do it. Gas clouds don't do it. Transmitters do it. And this one drifted in frequency, exactly the way you'd expect from a transmitter sitting on a moving planet. The team called it Breakthrough Listen Candidate 1. The first signal in the project's history series, enough to earn a name. For a year, it was analyzed in secret. Was this the one? In the end, probably not. The investigation concluded it was most likely human-made interference, a distorted echo of our own technology, because look, alike signatures turned up at other frequencies. But it never repeated. Its exact source was never found. And it remains the closest thing to a genuine candidate that modern SET has ever logged. The star next door pinged us once, and we still can't fully prove it was us. Number 2. Oumuamua. October 2017. A telescope in Hawaii picks up something moving too fast to be from here. Its orbit didn't loop around the Sun. It came from interstellar space, the first confirmed visitor from another star system in recorded history. And almost nothing about it behaved. Its brightness swung so wildly that it had to be shaped like nothing we'd seen. Maybe 10 times longer than it was wide. A cigar, or a pancake, made of rock, or ice, or something we couldn't pin down. Because it showed no tail and no cloud of gas. Nothing a comet should show. And then, as it left, came the detail that still keeps astronomers up at night. It accelerated. Not much, but measurably. And not because of gravity. Comets accelerate when their ice boils off and pushes them like a tiny engine. But we saw no ice boiling off. Oumuamua. Theories exist. invisible hydrogen outgassing, exotic nitrogen ice, and yes, one Harvard astronomer's suggestion that we shouldn't rule out technology. None has been confirmed. It's gone now. Too far and too fast to chase. We had 11 days of good data, and we will argue about them for a century. And number 1. The signal that started it all. August 15th, 1977. The Big Ear radio telescope in Ohio is running an automated sky survey, printing the intensity of radio noise as columns of numbers and letters. Days later, astronomer Jerry Eman is checking the printout at his kitchen table when he stops at one column, 6EQUJ5, a signal rising and falling over 72 seconds, exactly the profile a distant transmitter would trace as the Earth's rotation swept the telescope's beam across it. 30 times louder than the background, and parked almost exactly at 1420 megahertz, the frequency of hydrogen, the one-channel scientists had predicted any civilization would use to say hello, because hydrogen is the most common thing in the universe. Eamon circled the column in red ink and wrote one word in the margin. Wow, nearly 50 years later, that page is still the best candidate we have ever recorded. And here's what makes it hurt. We looked again, dozens of times, with better telescopes, at the same patch of sky in Sagittarius. Silence. Every explanation proposed since, comets, satellites, reflections, has failed to fully fit the data. The wow signal did exactly what a deliberate transmission would do, and exactly what a glitch would do. It happened once. So, that's the scoreboard. A microwave oven. Solved. A false alarm from the star next door. Probably solved. An interstellar visitor that accelerated. Unresolved. And 72 seconds from 1977 that no one has ever explained or repeated. 2 out of 4. That's science working exactly as it should, and it's also why the remaining 2 are so hard to dismiss. The same methods that ruthlessly killed the fake mysteries have failed to kill these. Here's the thought I'll leave you with. The universe has been sending us radio noise for 13 billion years, and we've only been listening for about 70. That's not a search. That's pressing your ear to the door for half a second and deciding the house is empty. Signals that happen once may simply be signals we started listening to too late or stopped listening to too soon. So tell me in the comments, which one do you think we got wrong? The one we explained away, or the one we never explained at all? Subscribe if you want to be here when the next signal arrives, because the telescopes are still listening, and one column of numbers is all it takes. This is Odd Signal. Keep listening for the strange ones.